Hello! This video is going to cover properties. I'm going to cover 3 properties in particular, and all 3 of them apply to addition and multiplication. Now I want you to write these down. I definitely want all 3 of these to be written down in your notes. It's something that I will never test you on. I'll never ask you for a definition of any of these properties, but if you can understand them and how they work and why they work, it will prove to be helpful to you in math, which I'll kind of show in this video. The first one is the commutative property. Now, commutative property applies to addition and it applies to multiplication. Now, some of you may be wondering, why don't you just write addition and multiplication? Because you see my definition here. You can add the numbers in any order and it won't change the sum. Or you can multiply in any order, it won't change the product. Like, why don't you say you could do it in any order? I didn't want you to think that something like this, 4 plus 2 times 5, that means you could do that in any order, because you can't. That means if it's all addition, you could do it in any order. If it's all multiplication, you could do it in any order, and that's why I have them listed separately. Now, to help me remember these, I try and come up with these little clues, and here's one of them, commute, okay? The A isn't there, it should be an E for the word commute. But if you ever listen to the news in the morning, and they always talk about the commute means move around. So the word itself, commute means to move around. And you can use that to help you remember the commutative property. What that says is if you have numbers like this, 6 plus 8 plus 4. Normally, our order of operations says you do addition, subtraction from left to right as it occurs. But 6 plus 8, you're like, oh gosh, that's a lot. And you might start counting on your fingers. But if you realize that commutative allows you to move these things around, you can actually say, well, you know what, I'm going to put that 8 on the end. Because I can do that. 6 plus 4 is 10, plus 8 is 18. That's a lot easier. That's how this would help you with addition. Multiplication, it's the same idea. So let me give you one for multiplication. If I did 10 times 3 times 9. By the way, I am going to be using a dot for multiplication almost always now. I'm going to stay away from the x because the x is going to be a variable and we're going to be using it a lot to solve equations. And it can be very confusing. So get used to me using the dot. All right, so this one, you look and you go, oh, well, that's easy. 10 times 3 is 30. I could do that. But then can you do 9 times 30? You should say, oh, yeah, I can. It's 270. But if you can't, because it's like it seems a little confusing, this is where the commutative property will help. Well, this is the same thing then. It's saying, well, I could do 3 times 9 first, and then put the times 10. 3 times 9 is 27, and I just put the 0 on for times 10. So it's 270. Okay? There's a commutative property for addition and multiplication. Now, let's move on to the associative property. Associative property, the root word that I want you to kind of look at is associate. And again, there should be an E on the end of that for the word associate. You may have heard your parents say, I don't like who you are associating with. And you might not know what that word means, but you know what they mean. They mean they don't like who you hang with, right? Or your group. So this is a grouping. And how do we show grouping in math? Is with parentheses. So, for this one, changing the grouping does not change the product. Oh, I put product. Haha, mistake. Changing the grouping does not change the sum for addition. Silly me. That would have been ticket worthy. All right, so changing the grouping does not change the sum. So, for an example of this one, I'll give you this. I'll say 5 plus 9 in parentheses plus 1. Here I have grouping, and now your order of operations, if you remember them, the grouping would come before the addition. It says, please excuse my dear Aunt Sally, where P is parentheses, so in other words, you'd have to do that. Some of you look at 5 plus 9, like, I don't like that. I don't, it's 14, but some of you may, again, start counting on your fingers. Your associative property would say, well, it's all addition, so it doesn't matter if you change the grouping. And what you could do is say, I'm going to do 5 plus 9 plus 1 instead. This is just 10. 10 plus 5 is 15. Same thing goes with multiplication. Let's say I had 2 times 8, and this was in parentheses, times 5. It looks like a decimal. Let me change that. Times 5. Here, you would have to do 2 times 8, which is 16, and then 16 times 5. Without your calculator, that could be a bit of a pain. But if you look and say it's all multiplication, so instead I'm going to do 2 times, and I'm going to move the parentheses here. 5 times 8 is 40, times 2 is 80. It made it much easier to do. Okay? So again, associative, associate, who you associate with, or you're grouping parentheses, they can be moved. If it's all addition, if it's all multiplication, you can move the parentheses around. And now we'll go to the last one for today. This is not the last of properties, but it's the last for today, is the inverse property. So I don't have a way for you to remember inverse property other than tell you that this word inverse means opposite, okay? So when you think about it, you could say opposite. There's no little trick like saying, oh, you're going to pull the root out. If you don't know the definition of that, now that's just one to kind of remember. Think about as the opposite property, but it is the inverse, okay? Now, here for addition, I have the sum of a number and its additive inverse. Now, that's something you're going to have to remember too. What is an additive inverse? And here in the next part, it says, or the opposite. That's what an additive inverse is, the opposite of the number, which is something you learned about earlier, is always 0. So, for example, if I have 5, here's an integer, and I said, what is its opposite? You should be able to say, well, it's negative 5. Okay, so the sum of a number and its opposite is always 0. This is something that I will prove to you later, okay? I promise I will when we cover adding integers. I'll go over that. But a number plus its opposite, or its additive inverse, is always equal to 0. The next one then, or I should say the last one, is multiplication. Inverse property is the product of a non-zero. In other words, it cannot be 0. And its multiplicative inverse. Now here's another one that you're going to have to know, the multiplicative inverse, which is the reciprocal, is always equal to 1. So if I have 1/2, for example, and I said I'm going to multiply, because it says the product of a non-zero number and its inverse, the reciprocal is just the fraction flipped over. Remember, if multiplying fractions, 1 times 2 is 2, 2 times 1 is 2, this is equal to 1. So and the definition says it's always equal to 1. Now, what happens if you have a whole number like this, and you want to multiply it by its multiplicative inverse? Well, first of all, you need to be able to turn that whole number into a fraction, which you should be able to do by just putting it over 1. What is the reciprocal of 5 over 1? It's 1 over 5. When you multiply, you get 5 over 5, which is 1. Again, it works. Okay? Now, one other thing I want to mention that doesn't have to do with properties, but it's something you're going to see a lot, and I want you to make sure you understand. If I have two variables written right next to each other like this, this means x times y. Same thing if I have a number next to a variable like this. This means that number times that variable, okay? That's the way that we show it. Because until we know what x is, until we know what y is, we can't actually multiply them. So we write them next to each other. It means x times y, or in the other one, it means 2 times x. Okay? That is all. Goodbye, everybody.